Okay, there it's recording. All right, so we're going to do the following question. This is page 29, Nelson Physics 12. Yeah, old textbook. All right. And the question is as follows. It says a hockey puck rebounds, so you want 27. So question number 27. Let's start with that one. It says a hockey puck rebounds from a board as shown in figure 16. The puck is in contact with the board for 2.5 milliseconds. So T is 2.5 milliseconds. Now how many milliseconds in a second? 1,000. So this is going to be 2.5 times 10 to the negative 3 seconds. Okay. All right. And then it says determine the average acceleration of the puck over the time interval. And your picture looks like this. This is what your picture looks like. You've got this, you've got that, and you've got this 22 degrees, and this right here is 22 degrees, and this is your VI, which is 26 meters per second, and this is your VF, which is 21 meters per second. Okay. All right, so what we're going to do, of course, as we said, was acceleration was delta V divided by T, and delta V equals to VF minus VI. And since this is a vector, that's delta V, which equals to VF plus negative VI. Okay, so what we're going to do is, this is my original VI, and I am going to turn it around. So it's going in the opposite direction. Okay, so because VI is what is negative. And these are my vector components. This is still 22 degrees. This is your negative VI, negative VIX, negative VIY. Of course, this right here, this is your VFX, and this is your VFY. Okay. Now what we're going to do is we're just going to go about solving the question as we normally solve it. So start with your delta Vx component, which is made up of the VIX plus VFX. Now remember what I said was there are two methods to solve this. One way is to do this, where you flip the vector. The other method is, forget about flipping. You're just going to subtract it right here. You're going to say VFX minus VIX. Now I want to show you with both methods. Okay, so hopefully, as I said, whichever method jives with you, whatever method you feel you understand better, you can use that method. I don't really care, as I've said, as long as you show me the work. You don't have to flip the vector business. You don't have to do that at all. Okay. All right. So your VIX. Now what we're going to have here is it's going to be cos of 22, and the speed was 26 meters per second. So this is 26. This is of course going west. Plus this one right here is cos of 22 again, and the speed is going 21 meters per second, and that is east. Yes. If you can please. Tell me what the numbers are. What is cos 22 times 26? How much? So this is 24.1 meters per second going west. And this one right here, 19.47 meters per second. And that is going east. Of course, we're going to subtract the two. So delta Vx comes out to 4.63 meters per second going west. So there's your x component of your delta V. Okay, we're going to continue, do the same thing for your delta Vy. Again, VIY plus VFY. Your VIY is sine, so that's sine of 22 times 26, and that is going north, plus sine of 22 times 21, and that is also going north, and that's also north right here. What do you get for your delta Vy? So 17.61 meters per second going north, plus, okay, so this one is 17 right here. Okay, sorry about that. So let's redo that. So repeat it again. What do you? 9.74 going north and 7.87 meters per second also going north. We're going to add the two together, and you end up with, because both of them are north, 17.61 meters per second going north. So of course, there's my Vx and Vy components. Are we okay with this? So far so good? Okay, so let us erase this and go to the next section. Okay, so now we're going to use Pythagorean to solve for it. Yes? Erase? Okay. Alright, so let's go solve for it. So you've got your delta V, which is made up of the square root of Vx squared plus Vy squared. And yes, I forgot, what was the Vx squared again? 4.63 squared plus 17.61 squared. What do you get for your delta V? By the way, this was going west and this was going north, correct? So north and west, and there is your theta. So tan inverse of 4.63 divided by 17.61. And what do you get here for your delta V? 15, 18.1 meters per second, 18.1 meters per second. 18.21. Okay, well, you're on my video. Okay. Are we good with this? Okay, what is your theta, tan inverse? Should all be doing it. Let's go, Bikram. $15 degrees west of north. Of course, we're not done. We're going to do acceleration. So acceleration is 18.21 divided by 2.5 milliseconds. So 2.5 times 10 to the negative 3. And what is your acceleration? 7.3 times 10 to the power of 3 meters per second squared, 15 degrees west of north. There is how you would do it. Number 27. Are we okay with this? Make sense? Yeah. See, yeah, we can do the other angle as well. So yes, you could do this angle right here, and that's going to be 75 west, or I should say north of west. Okay? Are we good? Okay, so let's do the next one. Now 29 is actually not that difficult. 29 is pretty straightforward. So I'm totally okay. Like, I think you could do 29. But 28, we'll do 28. Yes. You want to do the other way. Okay. So let's try doing it where we just subtract it. So exactly the same question again. We're not going to flip no vector. Okay. We're just going to try to do it as is. Okay, so we've got V1 and V final. VI, V final, and 22, 22, 26, 21. Correct? Okay, so now what we're going to do is we're going to say delta Vx is made up of Vfx minus Vix. Okay, minus. Now, as I said, for some people this might be easier. So we're going to say, well, what is your Vfx? Vfx is right there, cos of 22 times 21. And that is going east minus, and this is going to be cos of 22 times 26, and that is going west. So, can you give me the numbers again? 19.47 going east minus 24.1 going west. Okay, so of course we're going to subtract them, correct? What do you end up with? Yes, they do add. So it's going to be negative, negative. So what do you end up with? What do you get? How much? It's supposed to be 4.63. If 4.63 is if we add, no? If I added, if this was plus, then I can see how this might be subtracted. Okay, so we made a slight correction. Sorry about that. In the last slide, if you noticed, this was west and this was west right here. But it's supposed to be east because they're both going in the easterly direction. That's east right here. That is going east as well. Okay? So we're going to subtract the 2, and what you end up with right here, sorry? Negative. So it's going to be negative 4.63 going east. Of course, that's negative. We're going to convert it to positive, so it becomes 4.63 going west. There is your delta Vx component. Thank you. All right, now we're going to do the same thing with the Vy component. So delta Vy, which is Vfy minus Viy, okay? And you end up with Vfy, of course, is sine. So sine of 22 times 21, okay, that is going north. And that's going to be minus Viy, which is sine of 22 times 26, but that is going in the southerly direction. Okay, so what do you end up with here? What do you get your numbers? So 7.87 meters per second going north minus 9.74 meters per second going south. Okay, now of course these are both going south, so it's going to be we're going to make it turn around. We're going to turn it around, make the negative of it. So that's going to go north as well, so it's going to add the two together, and you end up with a delta Vy, which is 17.61 meters per second going north. So of course we're going to add the two instead of subtract, because that is south, that is north. And the rest of the question is exactly the same. Does that make sense? So either you flip the vector here and you do it all right there. Then you don't have to worry about doing it any further, or you do it the way, but you have to make sure you subtract rather than add. Is that okay? It's the same thing. You're going to get the same answer. The positive. That's correct. Yes. Yeah. The angle stays the same. See, the angle right here, what we do is if I flip the vector this way, I'm still using this angle right here, 22 degrees. That angle does not change. Okay? So hopefully that clarifies it. Okay? All right.